I present to you Emmy Noether, German mathematician, who her discoveries have been a great help to us today. Now, her discoveries were also impacted through her family and what she studied. So, she was born in 1882 in Germany from her father, Max Noether. So, she was actually born in a Jewish family. She was not the typical woman of the era. Although she was formed to teach English and French, she decided to diverge from this path, following her father's footsteps, who was a mathematician, and study at the University of Göttingen in mathematics. Although the University of Göttingen would only allow women to audit classes and not actually enroll. So she did that for a year, and in 1904, she left for the University of Erlangen to actually enroll this time and earn her PhD 3 years later with a thesis on algebraic invariance. A few years later, she decided to return to Göttingen on invitation by David Hilbert, one of her old professors whom she had audited. And together, they worked on Albert Einstein's newly published theory of general relativity, using Amy's work on invariance. Now, the theory had a loophole. It was not coherent with the conservation of energy. Emmy quickly saw the issue, and she demonstrated that energy cannot be conserved locally, so in a small space, and it could only be conserved in a large space. A few years later, at the age of 36, she made the discovery that there was a relationship between conservation laws and the symmetries of nature. So she named this theorem Noether's theorem. Basically, what it means is that for every symmetry, there is a corresponding conservation law. A conservation law is whatever you start with, you also have it at the end. It's a preserved quantity. Now, symmetries describe changes that can be made without altering how an object looks or acts. And it is a mathematical proof. Thanks to this discovery that helped the world of physics and mathematics, she was finally hired as a teacher in 1919 at the University of Göttingen. But she wasn't fully hired and didn't really get a paycheck until 1923, where she actually got her first paycheck. So she worked there for many years without ever being paid. She was a woman in a man's world, which was very hard for her, but she was absolutely brilliant. Over the next few years, though, she did a lot of research on the general theory of ideals. She focused her research also on non-commutative algebras, their linear transformations, and their application to the commutative number fields. So, in 1933, the Nazis took power of Germany, and they passed a new law that said that Jews could not teach unless they had been veterans of World War I. Since Emmy was not a veteran, she had to leave Germany. She left for the United States and went on to teach over there, but passed away a few years later. So her theorem is very important today. It helped with many conservation laws to understand them better. It is a great calculation tool, and it also helped develop quantum gravity theories. So, thanks to Noether's theorem, it helped build and establish the standard model of particle physics. And recently, in 2012, scientists were able to predict the existence of the Higgs boson, a tiny particle, all thanks to Noether's theorem. Her theorem is also applied in our day-to-day life. For example, in a game of pool. So if two pool balls collide on a table, they're going to collide in the exact same way, regardless of where they collide on the table, because the laws of physics are the same across the whole table. So thanks to her discovery, we can explain this phenomenon. Thank you.